Here's the explanation of pressure. The pressure in a liquid is the force per unit area exerted by the liquid. And at any point, the pressure is exerted equally in all directions. Also, pressure increases with depth. So here's a way of looking at it. Pressure exerted by a liquid at a depth h meters is the weight of a column of the liquid h meters deep with a base of 1 square meter. So we're talking about in the international system, or the metric system, and the units of pressure are force units of weight, which is newtons per square meter, newtons per meter squared. So here's how to think about it. Over here on this picture over here, got a little shark here going under the water there. You have a 1 square meter base column, rectangular column of the water from the surface h meters down. So how much would that weigh? So that's what the pressure is basically that weight. So h meters down, the pressure is the weight of the column per the 1 meter square base and h meters tall. So here we have it. Now, the volume of the column of the water in this case, or liquid, it's h meters tall, 1 square meter on the base, so that multiplies to h cubic meters. So the density comes in because you don't know what kind of liquid you're dealing with, oil, or you're talking about water, or seawater, a little different. So given the density here of the liquid, and that's given in mass per volume units, such as kilograms per cubic meters, then the weight, again using the metric system or the international system, it's mass times acceleration due to gravity, ma, so these are force, it's really the same as force. The weight is the density in kilograms per meter cubed times h meters cubed, so those cancel out, and that's how you get kilograms, so that's mass, that's good, times acceleration, that's g meters per second squared. Of course, g is 9.8 meters per second squared, so that's mass times acceleration, so that's your weight, and that comes out kilograms times meters per second squared. Kilograms times meters per second squared when those things cancel out. And of course that's a Newton. So you multiply the density times the depth, which is the h, times the gravity, 9.8, and that's in newtons. So the pressure is the weight per square meter. That's the definition of pressure. The weight per square meter, which is just the density depth times g newtons per square meter. Newtons per square meter. So think of pressure as the weight per the 1 square meter based column of liquid. So now what about force related to that? The force exerted by the pressure of the liquid on an object that is located at a constant depth down at h meters, like a flat plate laying down there, force is pressure at the depth of H times the area of the surface of the plate or the object at depth H. So I put in this area of the surface of the object, as long as it's flat, and exactly at the depth H. So pressure times area. Pressure times area, basically what it is. So force has the units of the pressure times the area. And of course those cancel out and you get newtons. So those are force units. Here's an example. The Mariana Trench is the deepest place in all the world's oceans. It's 6.8 miles deep, which is 10.9 kilometers. And here, over here on this map, is the Mariana Trench right in there. And so you can see in relation to with Japan, it's in the South Pacific over here, the Philippines. So right here. So you've heard about the Mariana Trench. Okay, so the question is, how much force is on a flat 2 square meter piece of metal laying on the bottom of the Mariana Trench? So we have to know the density of the seawater. Well, we looked that up. It's 1,027 kilograms per cubic meter. So that's what the density is. Then what kind of H are we dealing with? Remember, it was 10.9 times 10 to the third meters. That was from how deep it was, and that was from right here. 10.9 kilometers deep. 10.9 kilometers is 10.9 times 1,000 meters, because a kilometer is 1,000 meters. So the volume of a 1 square meter column that is that high, that deep. And then the gravity is 9.8 meters per second squared. So you multiply those numbers together, and the pressure at the bottom of the trench is going to be these numbers, and that works out in terms of newtons per square meter. Multiply it all together, and you get this many newtons per square meter. I want to know what that was in PSI, pounds per square inch. So I went online and got a converter for that. Put my number in for newtons per square meter, and it comes out right here. 15,911 PSI, pounds per square inch, and 15,911 is approximately 8 tons per square inch. Think of how much pressure that is. Every square inch, 8 tons on it. So the force on the 2 square meter metal plate at the bottom of the trench is force is pressure times area. So that's this number here. That's what the newtons per square meter of pressure was, times the 2 square meters. The meters squared cancel out. You get newtons. That's force. So here it is. And I want to know what that was in pounds. So I looked that converter up online, got this. So it's 49 million something pounds, which is 24,662 tons. Then I looked out how much an elephant weighs, and the big ones weigh about 8 tons. So how many 8 tons goes into 24,662? About 3,083. So when a metal plate is on the bottom of the Mariana Trench, it has such a force on it, it's the same as having 3,083 very large elephants like this over here sitting on it. So now you know why there is a submarine term called crush depth.